We're going to do a rundown of network devices in this video and the next one. Almost every IT specialist will have to interact with these sorts of devices on a regular basis. Cables allow you to form point-to-point networking connections. These are networks where only a single device at each end of the link exists. Not to knock point-to-point networking connections, but they're not super useful in a world with billions of computers. Luckily, there are network devices that allow for many computers to communicate with each other. The most simple of these devices is a hub. A hub is a physical layer device that allows for connections from many computers at once. All the devices connected to a hub will end up talking to all other devices at the same time. It's up to each system connected to the hub to determine if the incoming data was meant for them or to ignore it if it isn't. This causes a lot of noise on the network and creates what's called a collision domain. A collision domain is a network segment where only one device can communicate at a time. If multiple systems try sending data at the same time, the electrical pulses sent across the cable can interfere with each other. This causes these systems to have to wait for a quiet period before they try sending their data again. It really slows down network communications and is the primary reason hubs are fairly rare. They're mostly a historical artifact today. A much more common way of connecting many computers is with a more sophisticated device known as a network switch, originally known as a switching hub. A switch is very similar to a hub since you can connect many devices to it so they can communicate. The difference is that while a hub is a layer 1 or physical layer device, a switch is a layer 2 or data link device. This means that a switch can actually inspect the contents of the Ethernet protocol data being sent around the network, determine which system the data is intended for, and then only send that data to that one system. This reduces or even completely eliminates the size of collision domains on a network. If you guess that this will lead to fewer retransmissions and a higher overall throughput, you're right. Hubs and switches are the primary devices used to connect computers on a single network, usually referred to as a LAN or local area network. But we often want to send or receive data to computers on other networks. This is where routers come into play. A router is a device that knows how to forward data between independent networks. While a hub is a layer 1 device and a switch is a layer 2 device, a router operates at layer 3, a network layer. Just like a switch can inspect Ethernet data to determine where to send things, a router can inspect IP data to determine where to send things. Routers store internal tables containing information about how to route traffic between lots of different networks all over the world. The most common type of router you'll see is one for a home network or a small office. These devices generally don't have very detailed routing tables. The purpose of these routers is mainly just to take traffic originating from inside the home or office LAN and to forward it along to the ISP, or Internet Service Provider. Once traffic is at the ISP, a way more sophisticated type of router takes over. These core routers form the backbone of the Internet and are directly responsible for how we send and receive data all over the Internet every single day. Core ISP routers don't just handle a lot more traffic than a home or small office router, they also have to deal with much more complexity in making decisions about where to send traffic. A core router usually has many different connections to many other routers. Routers share data with each other via a protocol known as BGP, or Border Gateway Protocol, that lets them learn about the most optimal paths to forward traffic. When you open a web browser and load a web page, the traffic between computers and the web servers could have traveled over dozens of different routers. The internet is incredibly large and complicated, and routers are global guides for getting traffic to the right places.